All right, hello everybody. My name is Liam Howarth, and I'm a computer engineering student at the University of Oklahoma. Today I'm going to be going over integration by partial fractions. I aim to give you a conceptual understanding as well as a more algorithmic way to solve these problems. So when it comes to test time, you have kind of a step-by-step solution for these, and you don't really have to think about it. So conceptually, a rational function like this, it has really two kind of sides, right? It can be really easy. For example, like an integral of 1 over x. You have multiple ways to solve that integral. You can do power rule, or you can just understand that that is going to be ln absolute value of x plus c. And the same for this 1 over x minus a dx, which is just going to be ln absolute value x minus a plus c. And these are kind of the forms I'm going to get in today. That's why I introduced it to you. When I try to get these into forms like this, because these are pretty easy to solve. But there are plenty of other ways and other forms you can solve it with partial fractions. So that's the easy type of rational function to integrate. The hard type would be something like 3x plus 5 over x squared minus 4. I really don't. Without partial fractions, I don't know how to integrate that. I have no idea. So I'm going to show you how to use partial fractions to solve that. So the kind of ideas of partial fractions is that even with numerical values, for example, 5 over 6, you can break it down into simpler, smaller fractions, which in this case, smaller, simpler fractions that are going to be easier to integrate. So 5 over 6, you break that down into 1/2 plus 1/3, and it turns out that they equal each other. So we're going to find a way. I'm going to show you a way to turn that into some smaller fractions that you're going to hopefully know how to integrate. Okay. So first, the numerator is going to be important later, but you also don't care about it. That's just right now, you don't care about it, but you're going to really focus on the denominator right now. So what you do at the start of partial fractions is that you want to break down the denominator into the smallest linear factors you can. So for x squared minus 4, this is an easy example. You're just going to use difference of squares. So it's going to be x minus 2 and x plus 2. That looks like a bad x. X plus 2. And those are your two smallest factors, smallest linear factors you can get it into. Linear is important. There's ways to do it where it's unlinear, but you're pretty much just turning it linear to solve it. So I'm giving you a very easy example to start with. So linear meaning there's only one factor of x in these. So this is a pretty easy example to start with. So now that we know this is equal to that, right? So you want to break down this whole integral. You're going to break down it into integral. It's going to be a, where a is just a constant, like we talked about. If you're allowed to break this down into smaller fractions, you don't know what the constant is going to be for each of these denominators, but you know that there's a value that's going to make it true. So you're going to break it down to a over the first factor, x minus 2, and then you're going to add another constant we'll call b over the next x plus 2. And now it's kind of bad to say that you're solving the integral, because those aren't actually what's equivalent. Is that this is going to be equivalent. Just this rational function is going to be equivalent. So all we're saying is that 3x plus 5 is equal to x squared minus 4. And you're breaking it down in a way where you can solve for these constants and then plug it back into here and then integrate it. So now we want to solve for these constants. So the way we're going to do that is we're going to multiply by this. It's actually a bad example. Not a bad example, but I should have wrote the factors because it's going to make it a little easier. X minus 2 and then x plus 2. Just to make it a little easier to understand. So now you're going to multiply this denominator on both sides. So you pretty much, you're trying to get rid of the fractions so you can find and solve a and b. So you know you're multiplying both sides by, I'm gonna write it out for you, x, just this whole thing, x plus 2. I wrote it down here just because you're gonna see that it cancels. And then you also have to multiply this side. So it's this whole thing here. This marker is terrible. Sorry about that. So it's this whole thing right here multiplied by this denominator, which is x minus 2, x plus 2. And now what you're gonna see here is that this, you're multiplying this whole thing by both this term and this term. So you're gonna find that when you multiply, just pretend this doesn't exist. When you multiply these two by this, you're gonna find that these two terms are gonna cancel, and it's just gonna be a times the other term. So you're gonna get x plus 2a. And this is just this term, so now let's also do the other term. Pretending this doesn't exist right here. When you multiply this by this, you're gonna find that x plus 2 cancels. So you're gonna be left with x minus 2b, or b x minus 2, but let's write, keep it consistent, x minus 2b. And now we know that equals, since we cancel the denominator here, that's gonna equal 3x plus 5. And now, there's a lot of ways you can solve for these constants, but I'm gonna show you a very simple way. Let's take you over here. A very simple way that I like to do it is, I call it, you're gonna plug in nice numbers. That's a technique, very advanced technique. You're gonna plug in nice numbers. That's gonna make this solvable for one of these terms. So basically, you wanna turn these terms, these factors of x, you wanna turn that into a 0, so it'll cancel out one side, one constant, so you can solve for the other constant. So here, we know that if we plug in -2 for x, we know that that's gonna equal 0, which is gonna get rid of a just for this case specifically. And then we can solve for b in terms of x. So, well, in terms of x, where x equals -2. So we can solve for b for a numeric value. I'll show you. So we know that -2, we're gonna use x equals -2. So on the left side, it's gonna equal 3 times -2, which is -6, plus 5. That's gonna equal, we know this is just gonna cancel, so we don't even have to write this, but I'll write it out just so you have a understanding. It's gonna be 0a. And this right here, hopefully you can see, it's gonna be 0a, and then we're gonna add this term, we're at -2, so it's gonna be -4, -2 minus 2, -4, -4b. And now everything's numeric except for b. You know 0 just gets rid of a. You don't have to worry about that. You don't even have to write it, honestly. So you know that -4b is gonna equal, it's -6 plus 5, that's -1. So -1. And then you're gonna divide both sides by -4. And now it's gonna be 1/4 equals b. So we just found the numeric value for b. Now let's do a. Let me get rid of some of this. Or actually, let me just do it down here. I'll squat down a little so you can see. All right, so what's the nice number to solve for a? We can figure that out by, we know that we're gonna have to have a value for a, so a doesn't cancel. So we're gonna have to get rid of this term. So what makes this 0? That's just x equals 2. So let's solve for x equals 2. X equals 2. So on the left hand side, we're gonna do 3 times 2. That's gonna be equal to 6 plus 5. And that's gonna be equal to x plus 2. So 2 plus 2, which is 4a, plus I'm gonna write it out for you, but we know that this just cancels because 2 minus 2 equals 0. 0 times any constant is gonna be 0. So 0b, or you don't even have to write that, but on this side it's gonna be 11 equals to 4a, and then you're gonna divide both sides by 4. So now you know a is gonna be equal to 11 over 4. 11 is prime, so it doesn't. All right, so from here, let's get rid of some of this. I don't think I need any of this. No. I'll keep the math for you. Okay, so now we know that a is equals to 11 over 4 and b is equal to 1/4. So now we just go back. I did erase it, so I'm gonna rewrite it. This right here is gonna be equal to a over x. All right, I'm sorry about that. So we turn this rational function, split it up with partial fractions into a over x minus 2 plus b over x plus 2, where these two denominators are just the factors of x squared minus 4. And down here we solve for both a and b, where a is 11 over 4 and b is 1 over 4. So now I think we're ready to integrate, because we know you can integrate all together, but sometimes you're going to want to break it up. But here, in this case, I think it is fine to just integrate all together. We know that a is 11 over 4, so we just take that outside, actually. 11 over 4. No, we can't take that outside because it's not broken up. So yeah, let's break it up. I'm sorry about that. So this is gonna, I'm just gonna write it out. This is gonna be equal to the integral of a over x minus 2. This plus the integral b over x plus 2. Okay, so from here, we're gonna take that down here, and we're gonna plug in these values where a is 11 over 4. So we know that if you're just multiplying by a numeric constant, you would just take it outside of the integral. So we're gonna write 11 over 4, and that's gonna be the integral of 1 over x minus 2. And that's a very easy dx, I'm sorry. This needs to all have dx. And this is a very easy integral to solve, which I will show you here in a second. But this is gonna be plus the integral, which we have to do both. So the integral where b is 1/4, we'll just take that outside of the integral, and it's gonna be 1 over x plus 2 dx. And that's also a very easy integral to solve. So let's do it, let's solve it. So we know that the antiderivative of 1 over x minus 2, well, I think that's just gonna be ln absolute value x minus 2. I mean, that looks good. And then you're gonna multiply that by 11/4. So you can do 11 in the numerator, and then all divided by a denominator of 4. And then you're gonna add that to, well, I think this integral is just gonna be ln absolute value x plus 2. So we're gonna write that ln absolute value x plus 2. And then you're gonna divide by 4 plus c. So that's actually gonna be your final answer to this specific problem. In the next video, I'm gonna give you a more algorithmic, like step-by-step way to solve these for exams. But yeah, that's it for today, integration by partial fractions. Thank you guys.